Now, we need to find the product of fi and xi. Let sigma consider class interval 10 to 25. For interval 10 to 25, the frequency fi equals 2 and the class mark xi equals 17.5. Then fi xi equals 2 into 17.5. This is equal to 35. Consider next class interval 25 to 40. For interval 25 to 40, the frequency fi equals 3 and the class mark xi equals 32.5. Then fi xi equals 3 into 32.5. This is equal to 97.5. Consider next class interval 40 to 55. For interval 40 to 55, the frequency fi equals 7 and the class mark xi equals 47.5. Then fi xi equals 7 into 47.5. This is equal to 332.5. Consider next class interval 55 to 70. For interval 55 to 70, the frequency fi equals 6 and the class mark xi equals 62.5. Then fi xi equals 6 into 62.5. This is equal to 375. Consider next class interval 70 to 85. For interval 70 to 85, the frequency fi equals 6 and the class mark xi equals 77.5. Then fi xi equals 6 into 77.5. This is equal to 465. Consider next class interval 85 to 100. For interval 85 to 100, the frequency fi equals 6 and the class mark xi equals 92.5. Then fi xi equals 6 into 92.5. This is equal to 555. Now, arranging all the frequencies, number of students, observations, class marks, and given intervals in a table format, we have. From the table, we need to find sigma fi and sigma fi xi. Sigma fi is the sum of all the frequencies, that is, sigma fi equals 2 plus 3 plus 7 plus 6 plus 6 plus 6. This is equal to 30. Similarly, sigma fi xi is the sum of the values of product of fi and xi, that is, sigma fi xi equals 35.0 plus 97.5 plus 332.5 plus 375.0 plus 465.0 plus 555.0. This is equal to 1860.0. So, the mean x bar of the given data is x bar equals sigma fi xi by sigma fi. This is equal to 1860 by 30. This is equal to 62. Therefore, the mean mark of the class is 62. Let sigma now learn about finding the mean using assumed mean method. Assumed mean method. If x1, x2, x3, and so on, xn are observations, and frequencies f1, f2, f3, and so on, fn, are the numerically large numbers, then we consider assumed mean method or step deviation method. Given a large numbers of observations and frequencies, then finding the product of fi sigma and xi sigma becomes very tedious. So in this method we perform the following steps. Take the center or middle value of xi as the assumed mean. Then find the deviation di of all the xi sigma and the assumed mean. Here, deviation is the difference between each xi and a. Then, find the product of the fi sigma and the difference, or deviation. And finally, calculate the mean as sum of a and di. Let sigma see the steps in detail with an example. Step 1. If x1, x2, x3, x4, x5 are the given observations. Now, let us assume the mean, and denote it by a, which is known as assumed mean. Take the center value as a, that is, the center value of the given observations is x3, that is, a equals x3. Step 2. We find the deviation, di, of each xi, as the difference between a and each of the xi sigma, that is, di equals xi minus a. This implies that di equals xi minus x3, since a equals x3. Step 3. Find the product of di with the corresponding fi, and take the sum of all fi di sigma. Here d bar is the mean of deviations, that is, d bar equals sigma fi di by sigma fi, where di equals xi minus a. This implies that d bar equals sigma fi into xi minus a by sigma fi. This implies that d bar equals sigma fi xi by sigma fi minus sigma fi a by sigma fi. This implies that d bar equals x bar minus a into sigma fi by sigma fi, since x bar equals sigma fi xi by sigma fi. This implies that d bar equals x bar minus a. This implies that x bar equals a plus d bar, where d bar equals sigma fi di by sigma fi. Therefore, x bar equals a plus sigma fi di by sigma fi. Let's see some examples using the assumed mean method.